Hey guys, welcome back to another video. Today we're going to be using some multivariable calculus to solve a single variable calculus problem. Okay, so let's say you have a function f of x is equal to x squared sine x cosine x square root of x, right? So we have a very large product of a bunch of things being multiplied together, and we want f prime of x, or the derivative, right here, right? Thing is, like, we don't want to use the chain rule. We don't want to use the product rule because, like, it's a lot of work to go ahead and apply the same formula over and over again. Here's what we can do. First things first, we can go ahead and combine these two. Because remember our trig identity right here times 2. So this thing can simplify down to a 1/2 and then just sine of 2x root x, like that. Okay. Now we got that out of the way. First things first, we'll split it up into parts. We'll call this part A. We'll call this part B. And this last part C. Sorry, C. Now, here's what we got. We got f of x is equal to A, B, C. That's a little bit nicer than this. Okay, now, let's go ahead, calculate some derivatives of A, which is the derivative of 1/2 x squared is simply x. And then for B, and I don't know why I'm using partials, but whatever. And then for C, it's going to be 1 over 2 root x. Okay, so that's just some basic derivatives. Now, let's go ahead and calculate derivatives with respect to A, B, and C. So here's A. So that means A is the variable, B and C are the constants. It's a linear equation, we can just do that. And then sort of similar idea for B, it's going to be AC. And then for C, AB. Okay, so why did we do all this? Now, what we can do, we can apply the multivariable chain rule. So if we want to find the derivative of f with respect to x, we can take up all the partials. So here we have the partial with respect to A, but we have to get this in terms of x, so we multiply by x. And we can sort of think about the dA's canceling out, leaving just a partial f. And we sum up all the partials with respect to all of our variables. And this is a multivariable chain rule. Like that. Okay, so now let's see what we get. First things first, df, dA, that's right here, it's BC. And if you remember, B is sine 2x. C is root x. So there we go, BC. Times dA, dx, which is x. Next up, you add df, dB. Right here, which is AC. So 1/2 x squared root x times this, which is right here, 2 cosine x. So this 2's cancel out, and so we get x squared cosine of 2x times square root of x plus final part df dc, which is just AB. So 1/2 x squared sine of 2x times dc dx, or the 1/2 and the 1/2 become a 1/4, and then x squared divided by x square root of x. So we have x squared divided by square root of x, which is x squared times x to the negative 1/2, or just x to the 2 minus a half, which turns out to be x to the 1 and 1/2 or 3/2. There we go. So go ahead, put that right here. Okay, so here's our answer for our derivative. Now, whether or not this was easier than just applying the chain rule 3 times, I don't know. Definitely gives us some organization for our work, which I